we're going to talk about properties of parallel lines, okay? So I bet a lot of you already know this fact. We're going to call it as a first postulate of this. Was it first or? I think it may be the first. So write this down. Our postulate number 10. We're going to take this as truth. I think a lot of you already know this. If two parallel lines are cut by a transversal, then corresponding angles are, anybody want to guess what we're going to say after this? One person? This should be pretty obvious to us. And again, this is a postulate. We're going to take this as truth without really, without proving it or anything. Yes, sir, what do you think? One person, two, three? Oh, what do you think? How many people say congruent? Raise your hand. How many people have a different answer? You are all correct. Congruent is correct. Does this make sense? Is this pretty straightforward? Yeah. Okay, here's a picture. Oh, there's no picture, sorry. Okay, but here's a picture for on the right side. Take a look at this one right here. You see the two lines? Let's say that K and N are parallel. Okay? If K and N are parallel, what can you which one of these angles are the corresponding angles? 2 and 3. Jordan is correct. Does that make sense? So that's what they're saying. What do you then if K and N are parallel, what do we know? 2 and 3 are? Angle 2 and 3 are congruent. That's what we're saying. Any question? Easy enough? Okay, so this is our postulate, we're gonna take it as truth. Now, if that's true, that 2 and 3 are congruent, what can you tell me about angle 1? And some other angles. Can somebody tell me, like angle 1 and 3, can somebody tell me about angle 1 and 3? What do you guys know about angle 1 and 3? How about Katie? What do you think? They're congruent? Why do you say that? You're right. Yeah, it's because vertical angles are congruent, right? Do you not agree? Okay, so we know that angle 1 and 3 are congruent, correct? Of course, if K and N are what? This only works if K and N are parallel, okay? Now, then what about if angle 1 and 3 are congruent? What can you tell me about angle 1 and 2? Okay, how about Kaylee? They're congruent. Why do you say that? Kaylee? Exactly. 1 is congruent to 3 and 3 is congruent to 2. Does that sound familiar? That's called the what property? Transversal. Very good. So guess what? And there's a name for angle 1 and 2. Do you guys remember from yesterday? What do we call these? Hannah B, what do you think? Alternate interior angles is correct. So take a look at what this says. This is our theorem. We're going to be proving this in a minute. But we sort of did it by just looking at what's happening here. If two parallel lines are cut by a transversal, it starts exactly the same way as the postulate 10. If two parallel lines are cut by a transversal, then alternate interior angles are, anybody? Everybody, what do you think? Are? Congruent is correct. Okay. So write that down. So we're going to be actually proving that theorem, okay? And I think a lot of you could do it yourself. So let's take a look at this. As a matter of fact, who could tell me what, you know what? Why don't you tell me what the given then part of this proof might be? What's given to you? So within this conditionals, yes. Good. K and N are parallel. Are there any other ones that we need to tell you that's sort of given? But if you look at the picture, it's sort of obvious. But what about line T? Do we have to say something about line T? Yeah. Line T is a transversal, exactly right. So that's what is given. So K and N are parallel, as you can see right here. And transversal T cuts K and N. As you can see, that T is a transversal for line K and N. Okay? So, no, you don't have to write it down. Now, what is it that we have to prove? You should write the theorem, right? But what do you have to prove? It's in the book, by the way. So, what is it that we want to conclude? If this is true, we want to say, Brandon? Angle 1 and 2 are congruent. As a matter of fact, why don't you go ahead and prove this yourself? Go ahead. I'll wait. Okay, and of course you could ask your group. I bet a lot of you could just do it yourself. But help each other out, and I'll give you time. Okay, go ahead. You could ask your group members, see what they think. Go ahead. All right, so how many people started with the given?
I did.
Okay, but there are two. Which one did you guys start with? How about, let me ask Jake? I mean, not Jake. Jack.
I did perfect.
Huh?
K is
K is
perpendicular.
perpendicular?
No. Parallel.
Parallel. Okay, good. Then what did you guys do next? How about? I'm sorry. How about? Thank you. How about? Somebody that haven't called. How about? Youngwoo. Okay. But the transfer, so cause K and N, you can put that there. It doesn't really change much. What did you do next then? And then you did angle 1 equals angle 2?
Angle 3.
Oh, angle 3. Why? Very good. That's what actually they do that too. Could you have done something else? Did anybody do something else other than this? Yeah, because you don't have to do that one first. Kenneth?
I did angle 1, no, angle 3 is congruent to angle 3.
Yeah, so you could either do angle 3 congruent to angle 2 there, or 1 congruent to 3. Doesn't matter. So you're right. And of course, the reason for if you did 1 congruent to 3, it's because what? Vertical angles are congruent. And if you did the other one, angle 3 congruent to 2, it's because it's the postulate. If two parallel lines are cut by a transversal, then corresponding angles are congruent. Okay? And there's a reason why they did it this way. You don't have to. Because after this, what can we say? Look, angle 1 is congruent to 3, and 3 also is congruent to 2. That's the Michelle, what can I say? That's right. Angle 1 is congruent to angle 2 because how many people put down substitution? Raise your hand. Okay, that's how you get it wrong. Why can we not use substitution here?
Oh, I get it.
Yeah, because who can explain? Why can we not? Yes, sir.
I put substitution, but that's only for measurement.
Yeah, it's only for measurement. You're right. So what should you put down? Ethan, what do you think? That's exactly right. We need to put down transitive property of congruence. Yeah, question?
Why don't they do the second part like and then in the proof like?
Right. What? Because many times when you have this picture, it doesn't. So you could actually put that down there, but because they gave us this picture, we know that T, is a transversal. So you could actually put that down as a given in the very first. If there wasn't a picture, then you couldn't use angle 1, 2, 3, 4, things like that. But yeah, I would put all that stuff in there. Okay, does this make sense? Do you guys see why they do it this way? Now, if I did third step first, it doesn't matter. No, it doesn't matter, right? You could have done that and then angle, right? 1 is congruent. If I did this step first, I would have said angle 2 is congruent to angle 3, and then as a third step, I would have said angle 3 congruent to angle 1, right? And then say, angle 2 is congruent to angle 1, and then, you know what I mean? Then you get the statement you want, right? And then maybe you could use symmetric property of equality and say angle 1 is then congruent to angle 2 if you want to switch the order. Okay, any question? Easy? All right, there are other theorems, and notice the first postulate and then the theorem, they always start with if two parallel lines are cut by a transversal. Okay. The third theorem is going to start with that statement also. Okay. So let's take a look at our third theorem, and we have 2 more of these. You're going to be doing them for your homework, the proofs. Okay, for these theorems. Okay. But they're not that bad. Here we go. Who wants to read for us our second theorem of the day? Okay. Don't everybody go at once. Go ahead, Michelle. Go ahead. Anybody want to fill in the blank? Good, thank you. If two parallel lines are cut by a transversal, again, it's the same sort of, right, statement. Then the same side interior angles are going to be. How about David? Yes, supplementary. Supplementary. You're exactly right. So here's a picture. So what are they saying? In this picture, of course, K and N are parallel lines, and T is the transversal that K and N is being cut by. Then, which one of these 2 angles are congruent? They're saying. I mean, not congruent. Which one of these 2 angles are supplementary? Angle 1 and 4. Would you agree? If I had angle measure here, like 3, then 3 and 2 also will be supplementary. But that's sort of the same thing. So that's the picture, and here's what's given to you. And you got to prove that angle 1 is supplementary to angle 4. Let's go to the next theorem. Okay, who wants to read this for us here? Go ahead, Kenneth.
Transversal is perpendicular to one of 2 parallel lines, then it is
Perpendicular to, Jack, what do you think? If a transversal is, thank you, a perpendicular to one of two parallel lines, then it is perpendicular to. Let me give you a hint. Here's a picture. So what they're saying is, you got a transversal which is perpendicular to one of the two parallel lines. So in other words, L and N are parallel, right? You got a transversal. If this T is perpendicular to L, what can you tell me about T in terms of T and N? What sort of, yeah, it's perpendicular to, yes, the other one, exactly. So if a transversal is perpendicular to one of the two parallel lines, then it is perpendicular to the other one, okay, also. Okay. So again, I think this is your homework, isn't it? Yeah, there you go. So you're going to have this for your homework tonight. Go ahead and write it down. And you could do that one for your homework tonight. Who wants to read for us this paragraph here? All right, go ahead. Thank you, Brandon.
For the rest of this book, arrowheads will no longer be used in diagrams to suggest that a line extends in both directions without ending. Instead, pairs of arrowheads and double arrowheads when necessary will be used to indicate parallel lines as shown in the following example.
And here's an example right here. Okay. So take a look at this diagram. Notice we're not going to be using arrows for lines anymore because it sort of gets confusing with this symbol, right, to tell whether or not the two lines are parallel. So as you can see, we're going to be using arrows for indicating that the two lines are parallel. Is that okay? So here, this PQ, by the way, this is a line PQ, right? Because if it was a line segment, you would have endpoints on both ends, right? Sort of obvious. So here's a line, here's another line, they're parallel. What can you tell me about then? Measurement of angle PQR. Where is it? PQR, right? This angle. If this angle right here is 90 degrees, as you can see from the picture. Okay, a lot of you already know. Okay, how about, I haven't called Brandon, right? What do you think? What do you think the angle measure is? 90 degrees. How many people agree that's 90? Very good. You are correct. What tells you that that's 90? In other words, how would you justify your answer? Hannah, Lee, what do you think? How would you know that that angle is 90? Look at the theorems and postulate we studied today. It actually is one of those things. Which one of those says that angle PQR is 90 degrees? Sure, you could think of that as, so here, you could think of these, the line PQ and SR as a two parallel lines, because that's what it says right here. That's cut by a transversal QR. Okay, so sometimes if you get a picture like this, you might have to extend some of these things to see that the two lines are parallel, there's a transversal. Then, on these same side interior angles, you guys remember the river? You see that's inside the river. These are the same side interior angles. They are supplementary, we just learned that. So if this is 90, guess what? The other is also 90. There's another, actually another, you could use another theorem. Not only that one, some other theorem tells you that that's 90 also. Anybody see that one? One person see it? Two people see it? Take a look at the theorems and the postulates we learned. Not only can we use that one, the one that just Hannah said, we could actually use another one. 3, 4 people see it now? 5? Madison, what do you think? Oh, that's the one we just, Hannah told us. If two parallel lines are cut by a transversal, then same side anterior angles are supplementary. Okay, Jocelyn, what do you think?
The transversal is perpendicular to one of the two parallel lines, then it's perpendicular to the other one.
Yeah, it's the one that we just talked about, right here. Right? If a transversal is perpendicular to one of the two parallel lines, isn't that what we have here? Here's a transversal, PQR, perpendicular to one of the parallel line, RS. Then what? Guess what? This transversal is going to be also perpendicular to the other line, which is PQ. Does that make sense? So you could use one of those two. I'm sorry? No, you don't have to write that. It's in your book. But actually, example 2, I want you to all try. Is that okay? So hold on. And let's do example 2. Everybody write this down. Hold on. Then I want you to all try example 2. Write this down. And draw the picture. tell me the values of x, y, z. Okay? Go ahead. And of course, you could talk to your neighbors. I mean, not your neighbor, your groups. Okay? And help each other out. Go ahead. I'll wait. That's a good question. Guys, how come there's only one arrows here and then two arrows over here for C and D? Why don't they just put one arrows for all four lines? Why do they put two arrows for C and D and one arrow for A and B? Narek?
Saying that the ones with the 2 arrows are perpendicular.
Yeah, exactly. So these are, C and D are parallel and A and B are parallel, right? Not all of them are parallel, right? If I were to put all one arrows for all four lines, would that make sense? No, that would mean all four of them are parallel, but they intersect. Okay, it can't be. Does that make sense? That's why they put separate. Was that your question? Okay, anybody need more time? Okay, go ahead. Come on, guys, you could help each other out. That's fine. Talk to your group. Okay? All right. Reagan, what do you think? What should we do? Let's find x. Reagan, were you able to find x? What did you get as the answer? 20. How many people wrote 20 for x? Very good. Very good. How many people have something else? Okay. Turns out it is 20, but let me show you how you could actually do this sort of. There's a little trick you could do. There's so many lines. If you want to find x, all you have to do is just hide line C right here. Don't worry about the line C. Just look at it this way. Because if you look at it this way, then you have two parallel lines cut by a transversal, and here's your river, right? Does that make sense? Does that make sense? So this is sort of a trick. If it gets sort of confusing, just hide one of the lines that does not really help you, look for these variables. So what you do is you hide the line that doesn't help us, and here's our river. What kind of angles are these? Angle right here and this angle, 2x and 40. These are the alternate interior, aren't they? The alternate interior angles. And what do you know about alternate interior angles, guys? They are congruent. So of course x is 20. Does that make sense? Do you see how you can find x? Okay, so whenever you have problems like this, just hide the line that doesn't help you. Okay. Next, let's then find y. In order to find the measurement of y, which lines do we not need? Which one could we hide so that we could find the measurement of y here? B, we don't need B. You are correct. It's kind of hard to do that. Okay. Whoops. So let's hide B here. Imagine that you don't have B, because if you hide B, alright, sort of hard. Okay, just imagine that it's not there. Then look at what you have. Y, right? And which one do we need? Angle 40. Look at this. These are your two parallel lines, right? Do you see that? And this line A is your transversal. Does that make sense? Then I guess I could try to hide it a little bit more. Right, then what can you tell me about angle y and 40 degrees? What kind of angles are these, class? Katie, what's the angle measure of y? 40 degrees. Does that make sense? You guys do you see what to do? Okay, then what about for z? Which line can we hide to figure out the measurement of z? Since we know the measurement of y and x, how about, Irene? Angle. We could get rid of a to find the measurement of z. Which lines do we not need? So we want to find the measurement of z. Okay, Irene, let me help you. If you were to get rid of line D, then you could actually figure out what angle measure z is. Because we know y, don't we? We just said y was 40, correct? Look, here are the two parallel lines, and here is the transversal. Remember, this is your river, okay? What do you know about, what kind of angles are these, y and z? These are the same side interior. And what do you know about y and z? They are supplementary. So if y is 40, guess what z is? 120. Does that make sense? Did you say 120? It should be 140. Yeah, 140. Does that make sense? Any question? Do you guys understand how to do this sort of problem?
Couldn't you also done it a different way when you look at x?
When you look at x?
Yeah.
Okay,
Same.
sure. If you know the x, yeah, okay, sure, you could do it. So which one do you want me to hide to get z? A? Okay, so, whoops. If you were to, let's see if that works, okay? If you were to get rid of the line A, sort of hard to do, okay? Then how would you find z?
Since you already know x is 20.
Right?
So, wait,
Yeah, that works. That works. Yeah, because here are the two. Here's the river. These are the two parallel lines. You know that x is 20, so this is 40. So z must be. They're supplement, right? Aren't they same side interior angles? 140 again. That works also. Does that make sense? There isn't just one way. This one happens. You could do it in two different ways. Are we okay with that one, guys? All right. Good. Now then, what I'm going to do is I'm going to show you the construction number 7. When is our quiz on construction? Friday. And I'm going to show you, I haven't shown you construction 7, right? So now I'm going to show you construction 7. I want you to take a look at it first. Don't do the construction yet. We'll do it after I show it to you, okay? Is that okay? All right, here we go. I want you to take a look at this construction. It's in that link also, okay? So let me show you. First, I want you to take a look at this. I have a line and a point outside a line, okay? And I want you to think about what I want to do here, Yomu, is I want to draw a line, construct a line that is parallel to this line PQ that passes through R. Does that make sense? Yes? Okay, so I want to draw a line right up here like this. That's going to be parallel to the line down here. Right, Grace? So to do that, what you're going to have to do first is, okay, sorry, here you are. Okay, first you have to draw a line through R to any point, as long as it intersects the line with a straight edge. Can we do that? This is easy. Does it have to be this angle, or could I do it this way? Yeah, it doesn't matter. Just draw a line, okay, that passes through R and hits the line PQ anywhere. Okay? Then what I'm going to do is I'm going to draw an arc this way from that intersection of this line to the other, and bring that up and draw another arc. Does this look familiar? When have we seen this before? Not really? No one sees when you've seen this before? Okay, let me do one more. Then I'm going to do is I'm going to measure the distance between this intersection to this intersection with a compass. Okay? And I'm going to move that over up here. Does this look familiar at all? No? We've actually done this. When have we done this? Not exactly, maybe, but. Yes, Hannah? Copying an angle. That's what we're doing. We're just copying an angle right here. RJQ. We're copying that angle RJQ to up here. Because all you have to do is when you connect, guess what you get? You get a parallel line. Because what do you know about corresponding angles of a parallel line that is cut by a transversal? They're congruent. So it's sort of using that postulate, right? But not exactly as the postulate, because that postulate tells us that we have a parallel line to start with, right? What do we have now? This is sort of a inverse of that postulate, isn't it? Because you have two lines cut by a transversal. We just made these two angles to be congruent. Then guess what? These two lines must be parallel. Does that make sense? And you see how they put that little marking there, saying that they're parallel. Do you want me to show you again? Yeah. Okay. So I'll run this. Okay. As you take a look at it, and I want you to do it yourself. Okay. And as you do them, I'm going to check your homework. Is that okay? Okay. So let me run this for you.